In a previous video I showed how to make up a high pressure air system from an old refrigerator compressor. This can also be done with an old air conditioner compressor as well. Today I'd like to show how to make a simple metal ball valve air cannon that can work with the high pressure air system. To make up a simple metal air cannon, you'll need the following items from Home Depot. A Milton 1/4" M style air coupler, because I've got a Milton 1/4" M style air chuck on the high pressure air system. I will need a 3/4" black iron pipe cap. I will need a 3/4" threaded black iron nipple. This one's a 6" You could use a larger one if you wanted, an 8 or a 10 or whatever you'd like. This is a 1/2" ball valve rated to 600 psi. Here I have a 3/4" threaded to 1/2" copper reducer. This allows a 1/2" copper pipe barrel to be connected. This gray barrel in the back is a 72" long piece of 1/2" copper pipe that's been spray painted silver. These are the parts you'll need to make up an all-metal air cannon. Tools and supplies for this quick little project are shown here. Some pliers, vice grips, a wrench. Now for the 1/4" M style coupler, you'll need a 7/16 drill bit, a 1/4 NPT tap, and some kind of electric or cordless drill to do the drilling with. Also, you'll need either thread tape or thread sealing compound to ensure that there are no leaks at any of the threaded connections. The first thing I'm going to do is take my 7/16 drill bit, and I'm going to drill a 7/16 hole roughly in the center of this pipe cap so that I can use the tap I mentioned to thread the hole so that my M style air chuck adapter will thread in there. So let's do that and show the result. Here I've drilled the hole now and I've run the tap into it. So I now have a threaded hole roughly in the center of the cap, and my M-style 1/4" air chuck fitting will thread in there. So now I just need to put some thread tape or sealers on the thread and wrench these two pieces together. I'll do that and show the result. Here I decided to put thread tape on the male threads and thread goop on the female threads. Now I'm going to assemble these two parts. I used the vice grips and the wrench to make sure that I got a very tight threaded fit here for no leaks. Now that the pipe cap has its air fitting, we need to mount the pipe cap onto one end of our 3/4" threaded black iron nipple that's our air reservoir. So I'm going to put thread tape on the male thread, and I'm going to put the thread goop on the female thread, and then very tightly wrench these two together so that again there's hopefully no air leak. Let's do this and then pick up the video again. Here the male thread on the 3/4" nipple has been taped, and the female thread in the 3/4" pipe cap that we prepared has been treated with the pipe goop. I'll now thread these two pieces together tightly. The pipe cap and its air fitting are now very tightly threaded onto the pipe nipple that forms our air reservoir. What we have to do next is put thread tape on these male threads and take our ball valve and put thread goo in its female threads, and then we need to thread the air chamber to the ball valve. So I'll prepare and do that now. I've put the thread tape and the pipe goo where they go. Now I will thread these two pieces together. And again, I'll take the wrenches to that connection and make it really tight and leak-proof. This assembly has now been tightened together with the wrench and vice grips. Hopefully it's leak-free. What we have as a result so far is an air chamber with a valve that can be pressurized, and then the valve used to suddenly release the pressure. What we need to do now is get our 1/2 inch to 3/4 reducer piece prepared and attached to the ball valve. So I'll be putting thread tape on the male copper threads, and I'll be putting thread sealing goo into the threads of the ball valve. I'll do this and then assemble these two pieces. The male threads have now been thread taped and the female threads prepared with the goo, so we can now screw our reducer on into the ball valve. And again, I will tighten that with the wrenches, and then we'll continue. What I'm going to do now is make a way so that my barrel, once I put it into the fitting, can be held there securely. So what I'm going to do is take a small drill bit and drill a hole right there through the adapter and my 1/2 inch pipe. I'm then going to thread it with an 832 tap and then put in an 832 machine screw to hold the barrel firmly in the adapter, and also, since this is muzzle loading, the screw protruding down into the barrel will prevent my ammo from going farther back than it should and winding up stuck in the valve, which we don't want. Let's go ahead and drill our hole. There we go. Now I just need to tap it and put the screw in. That hole was drilled with a 1/8 drill bit, and I'm now just removing the 832 tap. So our hole's threaded, and the machine screw will now just thread in. Now my barrel is firmly held in place. At this point, we've completed the air cannon. Let's zoom out here and have a look. Yes, we can see the whole thing now. It has the short barrel on it. This is now ready to be pressurized and tested by firing just air with no ammunition whatsoever. So let's pump it up and try it out. Everything's ready for the test. I've hooked up the high pressure air system to my air chuck on the new air cannon. The ball valve is in the closed position, so we can pressurize like so. Let's bring this up to 200 psi or so initially. Now, with it pressurized, to fire it, we just have to open our ball valve quickly. And it seems to work. We got a shot of air. Let's bring it up to 250 psi. There we go. And yes, this isn't leaking, and it will fire. Let's bring it up to 300 psi. There we go. And fire. This one's ready to be tested with a projectile in the short barrel. Let's move ahead and try that. It's time to test fire this with a glass marble as ammunition in the short copper barrel. There is the glass marble with a piece of tissue around it. It fits the barrel quite well. I've inserted my marble and tissue into the barrel, and I'll now use a wooden stick to push the marble and tissue all the way down my barrel. I should point out that this is a very short barrel, and it won't generate a lot of velocity. That's why I have the second silver-colored barrel that's 72 inches long. A longer barrel is better. My backstop for this experiment is a milk crate that's absolutely crammed with filthy old rags. These catch a lead slug or glass marble in the rags, and there's no ricochets. The target is going to be a piece of sheet aluminum painted white. So, let's grab the cannon. We'll pressurize to 350 psi for this test shot. We're at pressure, and fire. Well, it fired nicely, and with the glass marble, we got a nice hole clean through the plate aluminum. So there's some power to this little air cannon. As you can see, I've now mounted that silver-painted 72-inch long, half-inch copper barrel in replacement to the short barrel you can see in the middle there that I just test fired through a piece of sheet aluminum with a glass marble. I'm now going to switch to a cast lead slug for the test shot with the long barrel. Dead AA batteries fit a half-inch copper barrel quite nicely, so I'm going to load up with this dead AA battery, and the target is again going to be that piece of sheet aluminum in front of the rag-filled backstop. So let's pressurize and fire the battery through this aluminum. Let's try a AA battery, and then we'll try a lead slug. We'll pressurize to 400 psi for the battery. There's 400 psi and fire. Well, that knocked the target down, and we can see that the battery ripped a big hole right through the sheet aluminum. Here's some cast lead slugs for this new high pressure air cannon. I'll shoot one of them as a third test shot right now. I've loaded one of those cast lead slugs into the 72-inch barrel. The target this time is a piece of 5/8 inch thick particle core melamine. That rag backstop is behind it to catch the lead slug. Let's pressurize to 400 psi and see what the lead slug will do to this piece of wood. (350), 400 psi, and fire. The cannon is of course fired by very quickly opening the ball valve with your hand. As we can see here, that lead slug had no trouble at all whatsoever tearing a big hole right through that 5/8 inch thick melamine board. So this air cannon works quite well for a simple and quick do-it-yourself build that can be done for not very much money and not very much time. I have this extra air chuck and ball valve set up on the end of my high pressure air compressor's output line. What this does is lets me bring an air cannon up to pressure. I can then shut this fill valve here, the yellow handled ball valve. I can then remove the high pressure air line without losing the pressure in my cannon, allowing me to pick up the air cannon, aim, and fire it. That's why this assembly is here. This was a quick and easy and fairly cheap build to make an air cannon that can easily take up to 500 psi and can shoot lead slugs, AA batteries, glass marbles, or anything else you can get to fit down the barrel. Modifications to this could include working out some kind of a tension spring assembly to pull the valve open much more quickly. The quicker you can open the valve, the more velocity you'll get from your air cannon, but as you can see, this one will do a fair bit just by hand opening of the ball valve, but it's easier to aim if you work out some kind of spring and trigger arrangement to pull it open. Thanks for watching this video about making up a simple air cannon to work with your high pressure air system. This air cannon worked quite well, can shoot different ammo, and is easy to operate. Although there are other valves that are probably better for making an air cannon, say a modified sprinkler valve or making your own piston valve, these are all a little more difficult than this very simple ball valve air cannon that I've shown. Pretty much anyone with a few tools can make up one of these, and it will also work off a normal air compressor at 125 psi, But it really comes to life if you happen to have a converted refrigerator air compressor that's giving you high pressure air up to maybe 500 or 600 psi. The extra pressure really brings an air cannon to life, but to use high pressure you should be making it out of metal like this one is. Cannons made from plastic pipe should probably be restricted to normal air compressors of 125 psi, and I may make up a simple plastic air cannon in a future video. Thanks for watching, and I hope this information was interesting and useful to you. There'll be, as always, plenty more to come.